so maybe Kaushik can take a stab at it.
Whoa, what?
I know, right? I'm throwing a ball at you because I don't want to do it.
No, but
I love it.
oh, man.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. So Kaushik, how have things been?
Today was the great announcement that I think everyone was super distracted by. Google announced the Pixel phones. So for the folks who are listening today, they probably would have already found out all the news that they need to. But yeah, exciting day.
Yes, it is. Exactly. Are you going to get one or what?
Oh, definitely. I've been pining for a smaller, higher spec phone. So the Pixel, regular sized Pixel, the 5-inch one is what I'm going to get. What about you?
I think I'm going to get one too. I'm also in the same boat. I have a 6P, but it's just a little too big. And I really liked my Nexus 5. I liked that form factor. So I'm looking forward to going back down a little bit smaller, but having the same power. So really interested to see how that goes.
Nice. And because we're talking about things that we're excited about, we have someone special with us today who would also be speaking about testing with us.
Who did you invite on this time, Kaushik?
So before I start, I must say, like, the women in Android development are basically rock stars.
They are.
They do 5 or 10 things. Like, they sketch note, they're probably GDEs, they have like a video show going on, they have their great conference speakers. They don't just do 2 or 3 things well. They do like 10 things, and all of those 10 things, they do it exceptionally well. So in most cases, they kind of set the standard for most of us Android developers. So we're super stoked to have one of those who's been a very good friend of the show. So welcome to the show, Chiu-Ki.
Hello.
Chiu-Ki, for the listeners who haven't heard of you before or are not familiar with you, would you mind giving a little background about yourself? Maybe where you have worked, your history in technology, and maybe even kind of where you work today or what you're doing today in Android?
Sure. I've been working on Android for a while, actually, since the beginning. But I also have a little bit of web experience. I don't talk about that as much most of the time, just because there's so much to talk about in Android already. I'm a freelancer, so I work for different startups and write Android apps for them. And beyond that, how many of my side projects do you want me to go over? Because I have a lot of those.
Let's go over your favorite ones.
Well, I guess, okay, I have to plug my own show because this is free advertisement, right? I have a YouTube channel called Android Dialogs with Huan Tui Dao, which is, we interview people about Android. Sounds familiar. Except it's a YouTube channel, so it's not just voice. You can also see the people. And we do kind of code samples and a little bit of diagrams and stuff like that. So we take advantage of the visual side of it as well. So that's that. Let's see, what else should I tell you? I also organized a conference called 360 AnDev, which happened,
nice.
In July in Denver. I didn't see either of you there, but a lot of cool people showed up and gave great talks, and we hope to do it again next year. So it will be around that time frame.
One of my most serious cases of FOMO for this year was basically 360 AnDev, because unfortunately, I already had certain other plans like during that period, so I couldn't make it. But the talks were amazing. All the speakers who went that I've talked to have said, like, you folks did a fantastic job. And I guess like the talks are also going up online one by one now, right?
Yeah. So it's going up a little bit, not as fast as I'd like, mostly because RAM is helping us doing all the transcription. So it takes a little bit of time to process all of them, but they are of amazing quality, if I may say so myself.
Very true, very true.
Yeah, those videos have come out very nice. So I've been very impressed with the quality. So thank you for putting on the event, and thanks to the Realm for hosting the videos. That's fantastic.
Cool. Okay, I guess I'll talk about one more project, and then we'll go on with the show.
All right.
So I just want to talk about my newsletter about public speaking called Technically Speaking, just because I feel like more people should try to talk about what they know and share their knowledge, because as a community, that's how we grow. So I think we'll put a link in the show notes if people are interested in checking that out.
Makes sense.
Cool. Yeah, definitely. We can throw that in the show notes. No problem at all. So now we're here today to talk a little bit about various different things about testing, but one of the things that really comes up in every conversation, actually almost every single conversation that I get into eventually in regards to testing, is mocking in general, and kind of the big conversation of what is mocking? How do I do mocking? Are we doing mocking or are we doing stubbing? What's the difference? And a lot of people don't know a lot about that. So we're loving the opportunity to have you on the show so we can discuss this stuff. But before we really get into the guts of the show, I do have a quick question for you. And so I just want to start this off right. Which testing method do you prefer? Is it espresso, roboelectric, JVM unit test, or are you using something like Cucumber or some other crazy testing framework we don't know about? What's your preferred methodology?
Robodium.
Oh,
Is that a rhetorical question? I mostly use espresso, though these days I'm very curious about the MVP pattern to use with JVM as well. So I'm going to try that at some point, but so far I've been mostly doing espresso.
excellent.
Interesting. Don, I'm curious, what is your default approach?
I kind of use a hybrid approach, meaning that if I can write unit tests to run on the JVM, I'll write them because they're very fast, but there's also a ton of value in having fully functional tests, and Espresso does that very well. So I kind of use a kind of a hybrid of both of them. What about you?
If I'm developing something new, I go with the JVM JUnit route because I can sort of structure my app around using like the whole MVP pattern.
Mm-hmm.
But I mean, obviously Espresso is like almost indispensable because if you have legacy code or if you have code that doesn't lend itself that easily to the new pattern, then Espresso is the way to go, right?
Definitely would agree. It's so much, once you start wrapping your head around it and being able to do certain things with Espresso, it's really nice, which kind of is a perfect segue into the topic of mocking, because you get into these weird situations when you're writing tests and you need to make sure that you're providing, maybe a particular, I think it's hermetic is how you properly say it. Please correct me if I'm pronouncing that wrong, either one of you. Hermetic environment where we can make sure that we're actually in an environment where we know what the inputs are going to be and it's consistent every single time. And sometimes we can't rely on the network. Sometimes we can't rely on the file system. Sometimes we can't rely on various different things inside of Android. So it's good to start using mocking. So I think it would be good maybe if you could help us, Chiu-Ki, help us understand maybe a little bit about what mocking is. Do you have a good definition of mocking in general?
Yeah, the way I look at it is basically kind of what you described, right? If I want to test part of my system and I want to make sure that every time I run this test, I know that it's going to be testing the part that I want to test rather than whether my network is down or the other thing. So mocking allows you to take a dependency and then provide your own implementation rather than relying on an external dependency.
When testing nerds usually start having a conversation that gets like fired up, usually this point that Don, you brought up, like the hermetic environment invariably comes up. So what's special about it, and how does like mocking specifically help with that? Is it because any external, like it allows like a safe environment where you know what's happening? Like what's the deal with the whole like hermetic environment, right? Like, is that just like a fancy name for something simple? Like,
And why should we care, really? Yeah.
Well, the way I look at it is you want to know what you're starting your app in, right? So for example, say you're doing something where most of our apps probably uses shared preferences, which by definition, the whole point you're trying to do is save some state so that you can bring your app up to a certain state at some point. But if you think about it, right? So if I have a shared preferences that writes a value that says, what is your favorite animal? And I write cat, right? So that next time it can greet me, hey, here I have a cute kitty picture. If you are running this test and next time you are trying to test, what if the person said dog? You don't know whether you're starting your app with someone telling you already saying cat, because if you have the real shared preferences, it will have saved that preference already and will have already shown a kitten and having no chance for the dog person to express his love for puppies. So if you have a hermetic environment on the other hand, then you can have a mocked shared preferences essentially, which you know that when you start, you're always having an empty shared preferences. And then that allows you to test your app knowing that nobody has told it that it likes kittens.
Gotcha. That makes sense.
This is kind of even digging into the weeds a little bit, but can you actually mock out shared preferences in Android with any of the open source mocking tools that are available?
Answer is yes. But yeah, this really gets into the detail. So there are multiple ways of mocking things, right? So one thing you can do is, for example, in the case of shared preferences, what I usually do, I will have, instead of an on-disk implementation, which is what Android provides, I will have an in-memory implementation, meaning that each time I restart the app, you get a fresh copy of the memory, so it's blank. So that is not really a mock. This is more like a fake implementation. I'm sure you can also do something such that you will mock out the shared preferences so that when you say put, it will kind of intercept that and do something different rather than writing the disk.
And I guess this is where like Dagger comes, well, not Dagger, dependency injection comes into the picture invariably, right? So usually the easiest way, like at least I feel that we could solve a lot of these problems is like even for shared preferences, if you can ask maybe like if you have say Dagger or some other dependency injection library, if you can set it up. So in your activity, you basically ask for the shared preferences and you don't honestly care where the shared preferences come from, right? Does it come from Android? As long as the activity just gets it from your dependency injection library. So then that's where like the whole mocking thing comes in, right? So what you could do in your test is basically when the activity pulls that, you can just like mock it out and send like a custom shared preferences or like send anything you want at that point, right?
Right. Yeah. And in fact, that's the only reason why I use dependency injections for testing, so that I can, like you said, when I'm testing, I will get a fake version and I can mock its behavior or stop its behavior so that I know what is going to happen rather than depending on the state of whichever external dependency that my app will actually be using in the real world.
I'd like to rewind a little bit for some of the folks out there that may be kind of on the getting just started in Android or maybe not familiar with some of these concepts. If we were to mock out the shared preferences, would you say it would be good to put these shared preferences behind some type of abstraction? It would be some type of interface that then would that you could then create a mock implementation around, and then on the production version, it would just delegate the work down to the actual real shared preferences. Is that what you would possibly do?
For the case of shared preferences, you don't actually need to have an extra interface. So what you could do is you could kind of subclass it, right? So you can extend shared preferences, but then just override all the methods and say that, oh, yeah, put it in the memory. In fact, there is a class in AOSP that does exactly that. I think it's from the calendar app or some like Google app that needed to test shared preferences. So I have copied that from AOSP into my project so many times, just so that I have an in-memory implementation. So yeah, for shared preferences, you don't need to have kind of define an interface and then have shared preferences as the implementation, because it's not final. You could extend it, but sometimes there are things that are final and you could not extend it. Then in that case, you would define your own interface and then you provide two implementation, one for your app and one for your test.
That makes sense. All right. So we talked about what mocking is in general, right? So let's maybe dive into a little details about what exactly stubbing is and like what the difference is between mocking and stubbing. Is it just like a pedantic difference? Chiu-Ki, you did mention like a fake implementation also some time back, right? So do you want to like take us through what you think the differences are? Like actually, what is the definition of stubbing?
I actually had to study that before coming on the show. Because I'm very practical. I just kind of do things and I don't really know the definition for these. But since I read up on it, I can tell you now. So all these things fall under the umbrella of test doubles, which is kind of like a stunt double. So instead of the real actor, you have somebody else doing the job. So under that umbrella of test doubles, we have, like what you said, you know what? Let me just look at my notes because there are 5 things and I'm seriously blanking out. So there's actually more than what I just said. So one thing you could do as a substitute of the real class is actually just a dummy. So a lot of us will probably do that, right? When you're trying to instantiate something for your test and you're like, I don't really care about this argument. So sometimes you may put a null in there or an empty string, knowing that nobody's ever going to use that value anyway. So that's one test double, which is kind of silly, but you need that because your constructor asked for it. So another one is fake, which is what I was describing earlier about the in-memory shared preferences. So a fake is kind of like the real thing. It has some functionality. So if you think about the in-memory shared preferences, I could actually just have a hash map backing it. So every time you put something in it, it will store it. And then when you get it, you will get back the value. So it's almost like the same thing in terms of functionality, but not quite. So that would be a fake. And then there is the stub, which I also sort of mentioned. So stub is kind of a fancy thing, which my way of thinking about it is I have this object that's kind of like the real object, but instead of writing a implementation, a complete implementation, all I do is just tell this object, like, hey, if someone called this function, just hand back this canned response. And so you're kind of just trying to teach this object very specific sequence of actions to do, which are the ones that your test is going to need so that you don't have to care about the rest. I don't know if you agree with that implementation. I don't think that's the official implementation of the Martin Fowler or whatever thing I was reading about. That hurt my head, to be completely honest. Because for the longest time, I thought Mockito is a mock thing, but then it sounds more like a stub thing.
Yeah. The funny thing is, that's why I very conveniently asked you and I didn't dive into it. But I think in general, the learning is don't dwell too much on the specific definitions. Read them. Definitely read the articles that everyone's mentioning here, because it sort of helps you understand so if you talk to another developer and they talk about mocking and stubbing, then you should know enough to be able to hold your own in that conversation. And that's all really you need, because when you're actually coding, you will invariably land up doing the right thing because you'll find out what's convenient, and you won't necessarily be thinking, oh, this has to be a mock or this has to be a test double, so I should be doing A or I should be doing B. You're in the end just going to pull Mockito or something, and then you're going to do what makes sense for your test. So don't worry too much about the definitions. Now, Don, I know you had like a great reference, an article reference. Do you want to tell us what that is?
The article reference the one that I always reference is the Martin Fowler article that defines basically where he outlines that mocks aren't stubs. And that's kind of where I learned originally about mocks and stubs. And the way that I always think of them is that a stub returns a controlled value. So it's going to be an input and an output that it's just going to be controlled. And it's just it's a dumb little object. And then mocks are used to verify behavior. So I can actually determine that a particular method was in fact called on some on some dependency, that if I have an order class and it's going to take it, or I have a customer class, it's going to take an order into it as a dependency. I want to verify that when I say get the number of orders or the total amount that this customer spent, I want to make sure that it calls a particular method on that order object, and a mock object will allow you to do that. A stub would not be able to. So that's kind of the article really dives into depth, and it does get a little bit pedantic, but it does make sense to really kind of understand those really two key differences, mainly because when you're using different mocking libraries, and especially in different languages, such as going from Java over to .NET to Ruby, different libraries will usually try to stick with the same semantics across the board, ensuring that mocks can be verified for their behavior, and stubs are usually used for basically controlled data.
Oh, that makes sense. So that's one good use case where it's nice to know specifically those differences, because if you're trying to pick a library, then you know, like from what they specify, the semantics between how those things would work.
Mm-hmm. Yeah, and usually I always ask myself a question when I'm writing a test: do I need to verify behavior on this thing that I'm mocking right now? And if it's yes, that means I need to use a mock. And if it's no, then it can be a stub. Now, certain libraries have these general overlap between mocks and stubs, where they can kind of both return controlled values. It's just at that point, like you said before, you're just using the tool to get to an end result.
Chiu-Ki, I had a question. So we talked about mocking, we talked about stubbing. All this is great, but in the end, how do I do mocking or stubbing? Like, how do I get this to work in my Android application?
So there are two sides to that question. So one is, how do you set up your app so that you can have mocks and stubs during testing?
Okay. Mm-hmm.
And then the other half is, now that you set it up, you have this mock thing, what exactly it is, how do I use it so that during my test, I can instruct the mock, hey, return me this thing so that I can verify my UI if I'm using Espresso. So the first part is kind of interesting because it gets into dependency injection, essentially, which is a very fancy term, but it literally just means that I have something, which is the app, that takes in some dependencies, such as I need to have some library to call the network, or I have something to store data, such as shared preferences, right? And then you can use dependency injection to provide those dependencies. So the way I usually set it up is that I will have Dagger 2 to be specific, as kind of a central repository of all these dependencies, right? And then I will have a mock application so that when I have the real application and then the mock application being the very specific application class in Android, so that when I want the set of dependencies for my app, it gets it from the actual application, and then when I need the set of dependencies for the test, I get it from the mock application, and then I will need a custom test runner so that instead of instantiating my real application, it will instantiate my mock application, which is actually, it extends from the real application, so it has all the functionality, except I override the part that provides the dependencies.
So when you say test runner, do you mean like the standard instrumentation test runner, or do you actually spin up something on your own?
So I extend that. So I don't know if folks are familiar with that, but if you have written any Android instrumentation test, you will see this line in your Gradle file that says something Android.JUnit runner.
Yeah.
That thing. Yeah. So that's actually the magic that glues together your app and your test. And if you want to do the mocking, you could write your own such that instead of instantiating your real app, you can instruct the test runner to instantiate that mock app, which would then give you a handle to the mock dependencies.
So we're basically having Dagger kind of wire everything up in tests so we get the mocks that we're expecting to work with, right?
Yeah. And to be honest, you don't actually need Dagger for that. I mean, what I described, like having a mock application and having a mock test runner to load. I mean, it's just give you a path to load something different during the test. You could also just spell it out by hand and say, okay, I have this function called provide shared preferences, and then I can have it return the in-memory one if it's coming through the mock application. So Dagger is just a easier way. I mean, once you go over your initial fear of, oh my God, there's this complicated library to use, it's just a convenient way for you to collect all these dependency, and then, because those dependencies will also depend on each other, and soon when you're rolling out by hand, things just get really messy.
Yeah. I think the reason why I say that, I just automatically say dependency injection because I've gone down that road of wiring everything up by hand and just seeing how painful it is that I don't even think about it anymore. Like, it's not even an option for me to do that anymore. So I always think, all right, well, let's just use dependency injection. So that's a good point.
Right. Whenever there's doubt, just resort to using dependency injection, because no, I mean, honestly, because in many a time people ask me like, oh, should I be using dependency injection? And I usually try to be very theoretically right and saying like, well, it depends on the size of your application, how far along your application is, you need it, you don't need it. And then I'm like, no, actually, you know what? It's just so beneficial that forget it. Just like add dependency injection. Like, yeah, you're going to bite the bullet for like 3 or 4 hours to get it wired up. But once you have it wired up, everything's just amazing and things just work out pretty well.
Well, I mean, I guess for me, I actually went through the exercise of doing it by hand just to understand what is dependency injection, because I was one of those people that thought, wow, this is such a big term. Like, what is it? But once I did the exercise once, A, I don't want to do it ever again. But B, I'm not afraid of it anymore. So going through that once actually has value, I think.
Right.
But only once. Then please use a library.
Right. So maybe that's the right thing to do.
And then there's the second part, which I was talking about. So once you have this all set up, once you're writing your test, then you have a way to provide some mocks. Then you actually need to write those mocks. For that, I use a library called Mockito, which out of all the definitions that we've been talking about, it can do stubbing and mocking, meaning that it could do those kind of like if someone called this function, return this canned result, or it can also do the verification to make sure that the behavior is right. So most of the time I just do the stubbing. Sometimes I also do the verification part.
Gotcha.
So Mockito actually has a kind of interesting syntax, which I'm not quite sure how to explain that over voice. So maybe Kaushik can take a stab at it.
Whoa, what?
I know, right? I'm throwing a ball at you because I don't want to do it.
No, but
I love it.
Oh man. Okay, so the way Mockito works is like there are two primary functions. So if you actually go to the link, and we'll add a link to that in the show notes. If you go to like Mockito's landing page, there are essentially two sets of things that they say that Mockito does. One is essentially verifications, like verifying interactions, I think is what they call.
Yep.
And the other is, what do they call it? Mocking interaction, I guess. Mocking and stubbing, right? So they're like two basic things that largely you use Mockito for, right? Let's actually take a step back. Like we kept throwing Mockito around, right? Let's actually, like for people who haven't used Mockito, they might actually be thinking like, what the hell we're talking about?
What is Mockito?
Yeah,
let's answer that question.
Right. So Mockito is basically a library. This is a Java library now. So it isn't anything Android related. This was a Java library that a person, and I had to look this up, I don't know this off the top of my head, Dan North, and apparently he was the person who came up with the concept of a behavior-driven development, BDD, which is very similar to 3DD, but that's something that we're definitely not going to get into now because that'll take us another 2 hours to explain.
Oh, yeah.
And he wrote this all the way back in 2008, right? So he came up with Mockito. Mockito is a library, to be clear. It isn't any pattern. It isn't anything specific that we're doing. It's basically a Java library that we use only for the purposes of testing. So once we have that out of the way, what does Mockito give us? Two things. It allows us to like do verifying interactions. That's the second part. And the more important part is it allows us to do mocking and stubbing. So like we talked about mocking and stubbing at the introduction of this episode. The reason we did that is because Mockito is typically how you would do that thing. So Mockito is the library that helps us. So there are two kinds, like, so as Chiu-Ki was saying, let's talk about how we actually would stub method calls, right? Now, the easiest way to do this is just looking at a test. If you see a test, and I mean, honestly, that's how I learned. I just looked at like some sample test cases and I was like, oh, it seems like that's how they're doing. So assuming you have a list that you want to mock, right? Maybe this is like a very funky list that comes from the server, but obviously in your test case, you don't care about how that list comes as long as you just have the list of elements with us. What would you do? You would do mock list, and you would just call Mockito's mock method. So this is basically like a static method that says mock, and it takes in a class definition. So you could say list.class, you can say, I don't know, set.class, you can say your object.class. It's basically like the definition of a class. So this isn't an instance of class, but it's the definition of a class that you would provide.
And this can also be an interface though too, right?
Actually, that's a great point that you brought up. Because you can also mock an interface, all that we care about is in the actual test, the specific method that gets called on that mock, we could basically stub those methods out, right? So we don't honestly even care about like the implementation. So we don't care if it's an array list. We don't care if it's like a tree list or like any of the other lists. All we care about is when somebody calls a method on this mock, does it have an answer? And Mockito is the way that we basically say, hey, I want to mock this object. And the next thing that you would do after you've created this definition of a mock is say, there are two ways of calling it. So one way is you call the when method. So this is WHEN. So when mock list dot, and then you actually call the method that you want. You can say then return. And because this is Java and we're in the land of Java, Java understands what the return type of those values should be. You can basically provide it a list. So you can say, hey, when someone calls list.get second element or get first element or get third element, you can say then return this string or then return this object, this order item object that I have in my application. So that's one option of basically stubbing and mocking. Anything else you think you should add?
Yeah, I think it's also important to note that if you're able to use an interface and you're following the segregated interface principle or whatever you're following. But if you're able to use an interface, and let's say you have a class that maybe is a customer class, I'll use that example again, and I want to go get all of the customers' previous orders. Normally that call would then go hit a database or it would go hit an API. We don't want that type of thing to happen. And if we're able to use an interface that let's say the customer class relies on a order service of some sort, and it's just an interface, an instance of an interface, we can then mock that interface that says, hey, get previous orders, which normally goes to an API. And in this case, we can actually return a consistent, repeatable list of orders that we want to test with. So we can throw a null one in there. We can see what happens. We can throw a one that has a very large amount in there, so we can see if our UI is going to react a certain way and so forth. So it does allow you to mock out those and get rid of those crazy other dependencies somewhere else in your application as well. So it has multiple uses.
Yeah, and once people start using Mockito, it basically is like magic. You enter the land of because testing suddenly becomes so much more easier, right?
Yep. Mm-hmm.
Yeah. Definitely. And I really like the thing that Don was talking about, doing error testing, because we all test the happy path, partly because it's just so hard to make it return a null from the database and that kind of thing.
Exactly.
Whereas, but Mockito just make it so easy. Just like, when someone called this function, just give them a null or give them a bad JSON and see what happens.
Yeah,
and you can even tell Mockito to do different things, and that's part of the method I think you're getting into is maybe the do return. You can tell it to throw exceptions. You can tell it to do all kinds of crazy stuff that you wouldn't normally be able to replicate in a regular manual tested application, at least not easily.
Yeah, and so that's like the second option. And I wanted to, after I explain this option, I want to ask you folks what you use. So basically when you use Mockito, there are two ways to do it. There's the more nicer API, which is like when, then. So it's like when mocklist dot blah, 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 then return blah, blah, blah. There's also another way, which I typically have always used. So it's exactly the same thing as when, then. It's just a different API, right? So it says, do return blah, 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 when, blah, 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 right? So when in the previous API, it was like when, say, I call it condition A. So when I say when A, then return list of elements. What you would do here is say, do return list of elements when A. So it's the exact same thing, but we're just like switching the API a little. So this is another variant of doing the same stubbing and mocking that we're talking about. And honestly, for the longest time, I always did use the do return call, but it actually only after yesterday when we decided to sort of talk with Chiu-Ki about this, did I actually research it and find out the specific differences. But before we get into that, have you folks run into situations where you've picked one over the other, or which one do you default to? So Chiu-Ki, why don't you start off by telling us if you had to stub your mocks, how do you usually do it?
Yeah, I usually do the when something, then something, just because it kind of flows better in terms of when you're reading it.
It reads well, yeah.
And also it is actually a fluent API. So you could say something like when this method is called, then return this, then return this, then return this. And then what happens is the subsequent call will get the other return values, which I don't think the other syntax can do.
Oh, I didn't know that. I've never used it that way. Oh, interesting.
Yeah.
You chain them, yeah. Yep, chain them.
Yeah, I don't do that a lot, but that is one option that I don't think the other syntax can do. But I do use the other syntax. Basically, I use the other syntax when I don't have a choice. For example, sometimes I need to mock a void method. Then you cannot do when something then return void that doesn't work, which took me forever to find, by the way. How do I mock this thing that doesn't return anything? So I think I use a do answer call, which is it's kind of the more general way of asking Mockito to do something, essentially. So do answer, and then I'll have a function body to actually work out what I want it to do rather than returning or throwing exception.
That makes perfect sense. Don, what about you?
I follow pretty much the same pattern that Chiu-Ki does. I like to use the when syntax. It flows very nice. It's very fluent. I can chain all the calls together very easily. There is caveats to that. Of course, I do like to use the do throw, which is I like to test a lot of my exception cases, which We have a lot of problems in Android with null pointer exceptions or IO exceptions. I like to try to test those as much as possible, and using do throw allows me to do that. I can basically say, do throw a IO exception when I attempt to set the value of some objects to this content stream of a string or whatever. So then I can actually test those weird environment changes. But then there's also I also need to verify sometimes that certain actions are being invoked on different arguments inside of a method call. And you can actually do that in Mockito too. And I'll use that with do answer. And that gets into like even more into the weeds here. But when I really want to get complicated, I usually end up hopping into do answer. But majority of the time, that's my flow is the when, and then do throw or do return for various ones, and then do answer for anything super complicated.
So quick follow-up question for both of you folks. So because like you both brought up excellent points, but the question I would ask is, okay, so Chiu-Ki, you said when you want to mock a void method, when do you actually really want to mock a void method, right? Do you want to mock a void method? So that's like a question that I had. Like, have you come across a case where you're like, oh my God, I just need to mock this void method?
Yeah. So one scenario was I'm trying to mock something that has a function called like set listener or something of that kind, which is void, right? So you set the listener, and then later this listener needs to do something. So what I would do is I'll do this, mock the method or stub. Like I said, this is very confusing. So stub this method so that I know when the app itself, right, called the set listener. So then what I can do is then, okay, this gets really complicated because then I will also use an argument captor so that I can actually capture the listener and stash it away so that later when I need to, because I'm basically pretending to be the library, right? So that I stash this listener away. And then later when I will actually need to invoke this listener, I can do that. So that's how I do that. That's why I would need to sub a void method, because there are cases when I would need the argument of the void method rather than the return value.
Most of the times when I want to mock a void, the reason why I'm doing it is because I want to verify interactions.
Exactly. So that's a beautiful segue. So like, Don, why don't you tell us about like verifying interactions?
Yeah. So just as I had spoke earlier about the mocks versus stub type of situation, sometimes in when you're doing testing, sometimes you're testing the actual state of the actual application. Is it in this particular state? That's the majority of unit tests that you're going to be writing. But sometimes you actually want to verify that you're actually calling save on a customer object. Like I want to verify that when I set the customer's name or whatever, something has happened, I want to verify that this method was actually called. Because if it's not, then we've kind of missed something inside of our application, or we're going to have a bug later on. And so sometimes I will mock out a particular class, and then I want to verify that, hey, in fact, maybe if I'm using some type of active record style of library, I want to verify that the save method was in fact called. And it doesn't do anything, it just does, returns a void. And at the same time, it allows me to also verify that maybe if it's something that does some type of counting, I may say, hey, I want to make sure that this was called 3 times during the iteration of this loop, that if something was iterated 3 times, then you can verify things with Mockito by using the verify syntax. And that's basically just saying, hey, verify that this object has its method called this many times. It could be 1 time, 2 times. You can even also say, hey, I'm in a situation where I'm going through this flow of the application, and this one method should never be called in this particular situation. And you can also verify that method was not called using the verify syntax. So there's a bunch of different ways that you could do something. And you could also verify that certain arguments were passed in and so forth as well.
I think the way we split it, so like we talked about verifying interactions just now, right? So like the previous thing that we talked about, that's Mockito helping us in setting up the test. But this verifying interactions that you talk about is actually Mockito helping us do actual tests, right? It's like almost like the assert that syntax, or like the assert syntax that we have. Like this is Mockito trying to test something versus it helping us set up the test.
Yeah, exactly. And what will happen is if for some reason I say, hey, Mockito, I'm basically telling Mockito, I expect that this object's going to have its save method called 1 time. And what will happen is if for some reason during the course of the test, when the test completes, Mockito will then check to say, hey, was this method called on this object? If it was not, then it will fail the test saying, hey, I expected this method on this object to be called one time. It was not. And then at that point, I realize, of course, I need to go fix the test or whatever.
Or even if it's called more than one time, then it lets us know that as well, right? So if you say it should be called one time, but it's called 3 times because like you have 3 developers coming in and like each going like trigger heavy with the saves on the database or something, then it will fail at that point as well because you're very explicit with the expectations.
It is, and that's actually a good thing because if you have things inside of list views or anything like that require scrolling and the screen is redrawing and you've accidentally put something inside of the onDraw method and you shouldn't have, and you're verifying that this should have only been called one time, you may never know that it's there because it's kind of working and you may get a little bit of jank and you don't know why and you're like, whatever, ship it. But if you're putting this verify call in there, you're going to immediately know like, oh, whoa, this was just called 56 times. And why was that called? Like, okay, I need to dig into this further. And it helps you identify problems real fast.
So Chiu-Ki, you very silently threw us like a crazy bombshell feature called argument captors, right? So you should, can you tell us more about that? Because I know that's a super nifty feature. So maybe we should just talk about that now.
Sure. So I guess I could do it like if say we're doing a shared preferences, right? So you could do something like when pref dot put like is called, then return something, for example. Well, actually, that one is a void method. But in any case, so say we actually wanted to know what you're putting into the shared preferences, right? Then what will you do is you will put in this thing called a argument captor. So you basically, first of all, you define the argument captor, and then instead of passing in a actual string into the parameter, what we'll do is we'll pass the argument captor dot capture. And what that does is magically, Mockito will hook it up so that that capture object will contain the value that is passed to it, by the actual app. And then later, what you can do is you can do get value or get values, depending on how many times this function is called. And then you can examine what has been passed into this function.
Ooh, that's super nifty. So what you're saying is, if I wanted to test the parameters that are being passed into like different methods, right? So it's not testing the method itself, which is what we talked about. If you want to test the actual like parameter calls inside,
I guess you can use it in many different ways. You could be like testing the parameter. I guess it's more like verifying the parameter that's called in.
Gotcha.
Or you could do something that is depending on what's passed in, you could react in a different way.
Oh, right.
I mean, I guess one way you could have done that is, I just know the sequence of calls that's coming in. So you could say then return. But sometimes you may not know, right? Then you may need to react on the parameter.
Gotcha. That makes a lot of sense. Cool. Mock web server. What's this thing? And Chiu-Ki, if people wanted to learn more about this, what are the resources that we can look at for this?
Right. So Mock Web Server is kind of an interesting library. It's a Java library, so you don't necessarily need to use it for Android, but of course I use it for Android. So what it is a local server that you can run alongside your app, so that instead of talking to your production server or your staging server, you actually have a server running on your phone itself, and then your app can talk to it. And it does what we talked about earlier, much like Mockito, like it does both stubbing and mocking. So what you could do is, for example, you can enqueue some responses so that every time your app hits the mock server, it will just return a canned response. So for example, it will be like, hey, what's the weather today? And then it can return sunny. So that then you can go ahead and check and make sure that your app is displaying the sun icon, for example. So that's how I actually do a lot of my development. I will set up the mock web server with my test, and then I will just specify what I expect the server to be doing, and then verify that, or not even verify because the app hasn't been written yet. And then I'll write the app and then write the UI so that it will fetch the response from within the phone itself rather than hitting the actual server, which sometimes the server team hasn't even written that yet, right? Because sometimes you develop a feature in parallel. So that's how I use web server. It's kind of nice because you don't necessarily need to use it with any particular library. This is literally an HTTP server. So whatever way you are talking to the internet, you can ask your app to talk to mock web server instead.
Okay. But so two quick things. You're going to be making a course on this, I hear, in Caster.io. Is that true?
Yeah, actually the introduction video is already out. So in that, I go through like what I talked about briefly, like what is it, like how does it work, and why would you need that? And then I also give a little teaser at the end so you know what else is coming. So people should watch that because it's free.
Definitely.
The introduction lesson.
We're going to add a link to that, the show notes. These Caster.io people, I don't know who they are, but they do an amazing job. So everyone should
And they don't plug their own thing at all.
I know. They're so humble. Like they just like don't talk about it at all ever. So that's one thing. The other quick thing I had is I thought Mock Web Server was like a part of OKHTTP or something. But is this like an independent library altogether?
So it is bundled with the OKHTTP library, but you don't need to be using OKHTTP in your app to use that.
Oh, okay.
Interesting. Okay. Wow.
So I guess the way to think about it is like when you do your Gradle dependency, you have some colons, right? So like it's like the group and the module and things like that. So it's under the same group as OKHTTP, but it's a different dependency. So you actually have to explicitly include it's OKHTTP colon mock web server, something of that kind. But it's actually a separate dependency, but it's just under the same group.
Oh, okay. And this is by the folks at Square then?
Yeah.
Yes.
Oh, okay.
So you know it's good.
Yeah. And we have officially plugged our Square library for the episode.
Square library of the episode.
Yeah.
Thank you, Jesse. Thank you, Jake. Thank you, everybody.
Yeah.
So there's some really cool things that you can do with Mockito and mocking and so forth, but it does seem to have a couple of limitations. And those seem to be that you can't mock final classes. You can't mock like anonymous classes, which that would be very difficult, and primitive types as well. So there are some things to also be aware of if you're going to be working with Mockito.
Oh, yeah, yeah, you bring up a good point. Like you can't mock those things. So even if you wanted, like if you had like a class that was final, so like immutable or something, then best of luck mocking that. You're not going to be able to do it, right?
Mm-hmm. Exactly.
Mockito doesn't also allow you to mock static stuff, if I remember right. And this is like, I've gotten to big arguments with most of my colleagues on this. I personally hate static methods, like almost to like it being a problem that I have. Like even if there's like a static method, I essentially wrap that thing behind something that's non-static. I supply it through Dagger or my dependency injection stuff. And then I do that because it allows me to test easily. And I can give an example of this. But have you run into situations? Because I mean, static methods are very, very common across like all the libraries that we use, right? Have you run into a situation where you've needed to do that? And like, do you think there are ways out of this?
To be completely honest, I couldn't think of a time when I feel like I need to mock a static method. Because usually what happens is if I wrote the static method, it's kind of just the style of how I use static method is usually because I am doing a helper method almost, right? So maybe I have something that manipulates some strings, which I don't necessarily need to mock it. It just does its thing. And in fact, what I will usually do is I will have a test on that static method instead. So instead of mocking the method and trying to have it do something different, I will just verify its behavior and then let the app use the real implementation. So most of the time, I don't really need to mock any static method. The only reason I can think of needing to do that is because it's from a library, so I don't control how people want to do things.
Exactly.
But most of the time, the reason why I need to use a library is because it's an external service integration. So maybe I'm using the Facebook SDK or some other SDK. So in that case, I will actually be not just mocking the one static method, but just mocking the whole thing. So I would, like you said, have a wrapper, but not necessarily because I need to get around the static method problem, but because I need to stop the behavior completely.
I also have solved this another way, which is known. It's not really widely known at all, but there's a developer by the name of Jean-Paul Boudhou.
Boudhou now?
Yeah. Who created what he called the static gateway pattern, which is doing exactly what you said, Kaushik, and you're just wrapping those static calls or that static class in basically an interface and a concrete class or an implementation of the interface, so you can easily mock it. And this is very common with a lot of like date time stuff, of a lot of like loggers and stuff like that.
Another thing I've heard people do is use this other library called PowerMock to mock static methods. But I mean, quite honestly, I've just I've not had success with PowerMock. Maybe it's because I've never gotten to the point of finding a way to use it. Like invariably, I'll just end up using the alternative. All right, this is all great stuff. Chiu-Ki, do you have any other resources you think that you can point us to? Like, because we know you're a big fan of like mocking and Mockito. Like, are there any other resources that you can point our listeners to that you think would be interesting?
Yeah, sorry about plugging my own stuff again, but I open sourced an app called FriendSpell. It's kind of an attempt to open source a complete app that has testing, because it's very rare like to see testing out in the wild. So it incorporates kind of different elements that we mentioned today. So it uses Mockito. It uses a lot of the different libraries that we mentioned, like Dagger 2, Espresso 2. And the one thing that I want to point out for people who would maybe want to look at the library is that, so the library, I mean, not the library, the app, what it does is actually it does this Google Plus login thing. That's the first thing it does before it does anything, which if you just think about it, it's like, how on earth am I going to mock that and have it in a hermetic environment?
Exactly.
So like I think that's kind of an interesting, just a demonstration of like how do you do all these advanced techniques of using Mockito, using the argument capture so that you can capture the listener and then have it play back later and things of that kind. So if people wanted to get a concrete example of all these different techniques, I would think that library will be a good one to take a look, even though I wrote it.
No, this is fantastic. This is, I mean, I basically wanted you to basically see it. And this is FriendSpell is what I think the repository is called, right?
Yes.
Perfect. Yeah.
Okay, Chiu-Ki, we really appreciate you coming on the show and sharing your vast knowledge about mocking and testing and stubbing and everything in that regard. We really do appreciate
Thank you.
If our listeners wanted to reach out to you, what's the best way that they can do that?
You can find me on Twitter. My handle is Chiu-Ki, Chiuki.
Excellent. And Kaushik, what's the best way for folks to reach out to you?
I am Kaushik Gopal on Twitter, and that's usually the best way to get me to respond quickly.
Right. And you can reach me at Don Felker on Twitter. That's it for the show, folks. Fragmented is hosted by Don Felker and Kaushik Gopal. That's us. We edit all of the Fragmented episodes ourselves. The amazing Sarah from the Spec Network helps with production assistance and wraps our final mix. Special thanks to Chiu-Ki, who took the time to speak with us, and our theme music is produced by Alan Taylor, and the ad music is also produced by Alan as well. You can find more episodes of the show on your favorite podcatcher, but we personally prefer Pocket Cast, but there's also Google Play Music and all the other ones though, but we gotta show the Pocket Cast love. Our website is fragmentedpodcast.com, and you can find the links to all of our stuff and everything we say on our show on our website. Thank you for listening. We'll catch you on the next episode.
Bye.
See ya.